Okay, today's section we're going to be working on solving exponential and logarithmic equations. This is going to require us to use some previous knowledge and properties of logs that we've learned in the past to help us solve the different types of equations that we could run into. So what I'd like to do is break this up into a handful of videos showing you 4 different types of equations that you could be solving, and showing you the properties from previous sections that we'll be using on a regular basis. So I'm gonna kind of go through this first one here. The first problem example tells us, it says if we have exponential equation, so we're dealing with an exponential equation at this point, not logs, and they have the same base, then we know that their exponents are going to be equal. So let's take a look at an example of that. Let's say, for instance, we had 2 to the x power equals 2 to the 4th power. And I want to see, I see that these bases are equal to each other. And so that statement on the set of notes said if the bases are equal to each other, then their exponents must be equal to each other as well. If that's the case, we can just simply solve for x because x is one of the exponents, but I want to show you why that works more specifically. So if we look at a previous property we had something that said log b of b equals to 1. Technically, why that equals to 1 is because the understood exponent right here is 1. So what we're going to get is a cancellation of this, making that equaling that part right there. So if we want to use this, we can say then log b of b to the x power must actually equal to x. So log b of b more or less canceling itself out, and so x and x is what is the reason why you get x. Well, we can use that to understand this. If I have a 2 base being raised to the x power, if I make this log base to 2, then that's in essence going to give me the same property. Log base 2 of 2 to the x, and of course if I do it to this side, I've also got to do it to this side, which is the 4th power. And then ultimately these cancel out, leaving me roughly x on the left side and 4 on the right side. And so what happens is there's no need to take this middle step. We can simply skip that and come down to here if we can create the same base. Now, you're not always going to have the luxury of having the same base. So if we had 2 to the x equaled, let's say, 8, instead of having to rewrite this as a logarithm to actually get the answer, I can actually just rewrite the 8 as a base of 2. And since we've learned our squares, our cubes, and our fourths and fifths, we know that 8 is the same thing as 2 to the 3rd, and so x would simply be equal to 3 in that particular case. So sometimes it requires rewriting a number to match up as a common base. So this particular step right here is not necessary. That's just the reason. This is a prior property that we learned in a prior section that allows this to work. So let's go back to the notes and let's look at this type of problem. So one of the first type of problem that you're going to see is you're going to see an exponential equation, and you're going to try to create the same base. If you can create the same base with the exponential equations, then you can make their exponents equal to each other. So let's take a look at example number 1. Example number 1 has us says solve 4 to 3x power equals 8 to the x plus 1. Well, neither one of them have the same base, but they both can be dropped down to a base of 2, and of course 4 would be changed to 2 squared and 8 would be changed to 2 to the third. And you can see here that we have to apply our exponent properties, and then we get 2 to the 6x power and 2 to the 3x plus 3 power, and we had to distribute that 3 there, power of 3. And so now, since they have the same base, that same 2 there, we're able to take the exponents and make an equation out of them and then solve for the x value. So this is an example of how we would create the same base in an exponential equation so that we could solve for the missing variable. So on sample problem 1, just go ahead and take some time now and see if you can figure out how to make the bases equal so that you can make the exponents equal. Okay, so if we look at this problem, the first one already has a base of 2. So I want to create a base of 2 with the second one. So 32 is the same thing as 2 to the 5th power. Of course, we had there previously x minus 1. So now I have to, I have the same base at this point. So now that I have 2 and 2, I can simply say that 4x is going to equal to 5 times x minus 1. And so now we have an easy algebraic problem to solve. We can say 4x equals to 5x minus 5. I can subtract 5x from both sides, which is going to give me a negative x equals to a negative 5, and then divide both sides by negative 1, saying that x is equal to 5, and we've solved the exponential equation by creating the same base. So that is an example of the first type of problem that you could see using exponential equations. In the subsequent videos, we'll show you different style of problems.